Am I audible to everyone? And are the slides visible? All right then. So, first I would like to introduce myself. I am Mukul Jain, your tutor of today, who will be teaching recursion and backtracking. Other than that, I am also the head of the programming club, software development division. Well, isn't that something confusing? Why, if I am the head of the software development division, then why I am taking a session on CP? Would be the first question that comes to your mind. And if it is not, it should. Well, the answer is that CP is important. CP will help you get internships, placements, and it will help you crack the online assessments or the online coding assessments that are taken by different companies. So therefore, even if you are in the field of development, if you are in the field of cybersecurity maybe, or any other thing, you should do CP. It also improves your problem solving. Although you would have heard of these things many times before in your college life, but yes, it is important. That's why everyone says that, and that's why I am saying that. So today's goal would be to understand recursion, understand applications of recursion, learn how to brute force using recursion, assess time complexity of recursive algorithms, and use backtracking for efficient brute force. So I hope you understand the term brute force and are also familiar with time complexity, as we have talked about it in the previous lecture. So here's a small recap on functions. How do we create a function in C++? How do we use them? So what is a function? A function is a block of code which runs the code inside with the parameters it is given. So what are the things that you can see in this small piece of code? We are given two integers. So those two integers, that is int a and int b, are the parameters of the function. The int word written before add is the it is the data type of what the function will return data type, and add is the name of the function. All right, am I clear? Is it making sense? Okay, so what do you think is recursion? Any idea you have about recursion? Repetition of some code. All right, others? Calling of itself, calling of function, and others? Any other answers? Function calling itself. Okay, then let's see what recursion is. So what is recursion? Recursion happens when a function calls itself on a different set of input parameters. Why is it written different? Different means okay. What I would like to tell about different here is that different means if there is a function and you call, like below you can see there is an example, factorial n is equal to factorial n minus 1 into n. So had I called the factorial n is equal to factorial n or something, that would have been the same code, and that would have not given me anything useful. So that's why there's different set of parameters. So it is used when the solution for current problems involves first solving a smaller sub problem. So any guesses that where can this be applicable? That where a current problem involves first solving a smaller problem, a smaller sub problem. Sum of n natural numbers, and an example here is factorial. So something where you are seeing a mathematical series, right? So at places where you can work with maths, where there is some logic that you can build upon some smaller sub problems, is where you can use recursion. And the initial questions that you would be doing will be series, because they are easy to understand and easy to grasp. And following those questions will come a little harder questions that will not have series, but will have sort of some problems which are being solved through some smaller sub problems. All right. So here's an example of a recursive function. A function that calls itself is a recursive function, directly or indirectly. By directly I mean that here the function sum 0 to n is calling itself sum 0 to n, right? You can see in the piece of code shown here. Yes? But what if there were two functions? Suppose there were two functions, let's say chicken and egg. And egg would call chicken and chicken would call egg. Would that be recursive? No. Well, it would be, because a function that calls itself is a recursive function directly or indirectly. Alright. So indirectly it is calling itself. Therefore we call that function recursive. Other than that, what can you see about this function here? Any particular things that would be important from the point of view of recursion that you can see in this code? A terminating condition. Anything else? Okay, let me answer then. So if it is a function that is calling itself, it has to stop somewhere, right? If it would call infinitely itself, then that would mean nothing. That would not give you an effective output, and that would not be useful to you. Therefore, there should be a base case or a terminating condition. Other thing is that, let me give you an example. Can you think of recursion at like walking? Like you are progressing towards the stage or the point where the base case is. Let's say you are coming from here, here is the base case, so you are walking towards it, right? But what if you were walking in the wrong direction? Would you reach the base case? So therefore a progression towards a base case is also necessary, and therefore you must take care of these things while creating a recursive function. And I hope the function is clear. What it does is, it is summing up the numbers from 0 to n. What happens is, if n is 0, 0 is returned, and if sum is not 0, sorry, n is not 0, then it adds n to the sum of what the previous numbers were. So n plus sum of n minus 1, n minus 1 plus sum of n minus 2. So is it making sense? So here's a mind map or a recursive tree of what I showed you just before. It is a recursive tree. A recursive tree is similar to a mind map of the function call. you can see each node or vertex is the function call. Value inside the node is the parameter. So if I were to call sum 0 to n from 3, it added 3 to the sum of 0 to 2, which further called sum of 0 to 1 plus 2, which further called sum of 0, which returned 0 plus 1. So can you see the progression? So here's a recursive tree. Previous example for n equal to 3. Recursive trees are useful to help us understand how the function acts. Now I'll elaborate on that a bit in the recursive call stack. Now what is a call stack, or what is a stack? Stack is a collection of objects placed on top of one another. So you keep on placing the objects one by one. So let's say this is a stack. So first, what would you call if you were to sum up 3 numbers for that function which I showed you? Sum of, in the you would first call the sum of n, right? So you would call sum 0 to n for 3, right? That you would place it in a stack. That 3 calls sum of 2. That is also placed in the stack. That 2 calls sum of 1. And finally, sum of 0. So here is where the control is. Now what begins? The functions start returning. At this point of time, they had not returned. They were just calling. Like if we go to the previous slide, they have not returned. First they have called, then they will return. Until and unless sum 0 to n minus 1 hasn't returned, how would the function sum 0 to n in 10 would return, right? So sum 0 returns 0. What would sum 1 do? Add 0 to 1 and that then return 1. What would sum 2 do? Add 1 to 2, returns 3. What would the final sum 3 do? 3 plus 3 and return 6. Very good. So it means that all of you are on the same page. And so when a recursion is executed, the function calls are placed in a stack. The first call is at the bottom of the stack and the last call is at the top, which you can see here and is clearly depicted in the diagram as well. After a call is executed, it is popped from the stack and the returned value is passed to the current top element. This also makes sense, right? Space complexity can be found using the size of the stack. So what is the size of the stack here? In terms of n, not in terms of 3. N plus 1. So you can say it as an order of n. So that would be the space complexity. So what is the basic structure of a recursive function? Parameters to start the function. That is a basic structure of a function actually. An appropriate base case to end the recursion, which we have already told. And recursively solve the subproblems, which we have also seen. And process the result and return the value. All makes sense. But something is missing. What is it? What is missing is the progression towards the base case, right? Progression towards the base case is also necessary. Although it is not a part of the basic structure, but it should be the part of your logic, which you are applying in your code. So, a tougher example. How many of you know about a Fibonacci sequence? I guess everyone here. So, what is a Fibonacci sequence? Third element is the sum of previous two elements. Alright. So, how would that be implemented as a recursive function? Is what is shown here. That is, if n is 0, you would return 0. If n is 1, you would return 1. Let's say n was 5. Then what would be returned? Sum of fib of 4 plus fib of 3. Alright. And what would fib of 4 return? Fib of 3 plus fib of 2. And what would fib 3 return? Fib of 2 plus fib of 1. So what would be the answer of fib of 5? Answers from that side. That side seems a little quiet. Or from this side also. Answers. It's not a very tough problem. Well, you can use a pen and pencils. Need not do mentally. Fib of 2, 1, fib of 3, fib of 4, fib of 5, 5, 5, 5 it is then. So when do we need recursion? Oh, other than that, I would also bring one thing more here, that when you called fib of 5, it had fib of 4 and fib of 3 called, right? Now fib of 4 calls fib of 3 again. So isn't fib of 3 being calculated twice? Is it? Is it or isn't? Those who are in favor of the motion that it is being called twice, raise your hands. And those who are against, and those who are not in both the parties, well, it is being called twice. Fib of 4 is calling fib of 3 and fib of 5 is calling fib of 3, and that is what is an overhead for this function and increases the time complexity. So the time complexity for this function would be, any ideas? Maybe the recursive tree which you are being shown on the right side could help you. Well, this is actually a tougher example for you, but you can try to find the time complexity of this function. Two to the power n, and can you tell us how it is achieved? So for you can be a little loud and a little confident as well. You are right. So there are two branches and it is separating every time in two branches. Is everyone okay with that? The confidence seems less. Well, when the confidence seems less or seems a little brittle, we need to prove things. And to prove things, we need maths. So let's use maths. Let's say the time complexity for fib of n is t of n, a variable, right? And the time complexity for fib of n minus 1 will be a little louder, t of n minus 1 plus t of n minus 2 near approximation for this can be like, can I say this t of n is equal to is less than 2 of t n minus 1. So can you see the doubling factor? Is the time complexity being doubled? It is. And hence what we are saying is the time complexity for this function is 2 to the power n, and it grows hugely with increasing n. So that is a small drawback here, but yes, we can improve that, and we'll see in our next few lectures how we can improve this complexity to O of n, from O of 2 raised to the power n to O of n. That's how simple it is. So when do we need recursion? Recursion is usually used in complex situations where iteration is not feasible. Am I clear with iteration here? Do you know what is iteration? Loops. That you traverse in loops, and that is called iteration. So isn't recursion kind of a loop? Yes, it is. So why iteration is not feasible and recursion is? Well, actually, recursion and iteration are feasible, and the problem comes that the function gets quite bigger when you write with iteration. But recursion is, in the recursive function, it is usually very small to code. So that's why we prefer recursion. And other thing that I told you before was about Fibonacci sequence, converting from O of 2 raised to the power n to O of n. That we'll see in dynamic programming in the next lecture, in the next few lectures that will be coming up. So we need recursion for brute forcing, backtracking, dynamic programming, graph tree problems, etc. And we'll see brute force and backtracking most probably today. So recursion versus iteration, that is the question of the century. Is the recursive version usually faster? Yes. Those who are saying yes could raise their hands. Could you raise your hands? And the others who say no, please raise your hand. And what about the rest? Which side would you prefer? Yes or no? Or cannot be determined? There's a third option as well. So those in favor of cannot be determined, please raise your hands. Well, Then let's give up the answer. The recursive version is usually a little slow because there's a stack involved. You have to put the numbers in the stack, you have to pop it back up. If there was a simple for loop, would you be using a stack? No. That would have been a lot faster. Does the recursive version usually use less memory? Those in favor of yes? No? So that's something which is quite clear. Well, because we are using stack uses memory. So obviously recursive version uses more memory. Why use recursion then? Well, recursion is used because it makes your code very small. And when you will study about trees, graphs, and other things, you would really see that let's say there's a very small code for a tree traversal. In recursion, it would complete in 3 to 4 lines, and in iteration, it would take 10 to 12 lines at least. So you can see the gap there. It's not visual or visible when you are doing smaller problems, when you are just at the beginning phase. But as you grow as a programmer, as a competitive programmer, you can see that there is actually a lot of role of recursion, and you'll respect that. So this is a factorial iterative problem, that is solve for a factorial in an iterative manner. So you can see the code that there's a function factorial. It takes an integer n. If n is equal to 0, 1 is returned, and we take a variable temp as n, and we keep on multiplying it from n to 1 in an iterative manner, and then finally temp is returned, right? There would be a small e here. So temp is returned, and this is quite intuitive, quite easy to grasp. So let's begin with our first quiz then. Write a recursive function to calculate the factorial of a number. And this time I will be coding along with you. You should not see the board. You should focus on your laptops, and then we'll compare our solutions. So I guess you would have done it by this time. And is the screen visible, or should I Wait, is it visible now? All right. So you can see this is the code for factorial, and I guess it will be easy to grasp and intuitive. Again, if n is equal to 0, we will return 1 because the factorial of 0 is 1. And if n is greater than 0, that is the else case comes, we'll return factorial n minus 1 into n. Making sense? Others? There? At the back? This side? All right. Now let's give you a small modification. So what would you think that here n, what can be the values of n such that the answer does not overflow? By overflowing, that int has a range, right? And what is that range? Nearly 2 to the power 31. Okay. So if that is the range, so what can be the values of n that would give an appropriate answer that is within that range? 11, 12, 13, numbers like these, right? Not more than that, I believe. So that creates a problem because C++ has only a small range and the numbers are going way bigger. So what to do? The answer to this problem is then, do you all follow the programming club on Instagram? If you don't, you should. And we just in LinkedIn. If you don't, you should. We just posted about small C++ tricks, and there you would find that we use const int mod as 10 raised to the power 9. Sorry, 10 raised to the power 9 plus 7. So we modulus the number by this large number so that every time we multiply, the number is within this range. Okay. Am I clear at the back? Are you understanding? So the problem is that we need numbers within this range, within the int range. Therefore, every time we multiply, we will take modulus of this modulus with this number. What is meant by modulus is remainder by this number, so that the number stays within the int range every time we multiply. Is it clear? So the next question would be, write an infinite recursive function that prints the number of time it has run so far. What should I write here to break a line, or to write the next number in the next line? Is there anyone who says ENDL? ENDL. Okay, so now, well, as a competitive programmer, you should not use ENDL because ENDL takes a lot of time in comparison to \n. Therefore, use \n wherever possible. and after this call the function with n plus 1. Simple. Can we move to the next question?
So, sir, every time it would print the number, like if n is 5, so 5, 4, 3, 2, 1.
Well, this time we are not going backwards. This time we are going forward.
So, up.
You will call this function like this. INF0. What would it do? It will print 0, cout 0, right? What it will call? It will call INF1, right? Then INF1 comes, it will print 1, it will call infinite 2.
Likewise, it will go on up to.
So the stack is, here is 0, 1, 2, it goes on. And since it is infinite, it has no limit.
So, time complexity.
Infinite. That's why it is infinite, right? There is no time complexity. That if you were to fix an answer, if you were to put a limit, how would you put a limit? Is that maybe you can do something like this. The terminating case or the base case would be if n equal to maybe 100, then return, right? This would be a base case. So now the time complexity, or it will run 100 times, right?
So, if we don't give a boundary condition, so it will like.
Yes. If you are walking and there is no one to stop you, will you stop? No. So that's what infinite recursion is like. Print a number in binary recursively. Now this is a harder question. And how many of you are familiar with binary numbers? Almost all. And if you aren't, you should. So how would you do it? I would give a small intuition with for this. That would be, what would you do? Like there is a number, let's say 13. So what would be the binary of 13? Binary of 13, right? And how do you calculate it? 13 remainder 2 comes 1. Sorry, divide by 2. 6, 0. Here comes 1, 1. Here 0, 1. And you go up, right? So what will you do? You will first call the function with n by 2. Then you will print its remainder and you will be going back up, right? So when here you call when n by 2, and then you print right. This is what happens. So n will first go to 13, will go to 6, 6 will go to 3, 3 will go to 1, it will go to 0, 0 will return. Then once 1 will be cout because the 1 remainder 2 is 1, then it will go back up. You see 3, 3's remainder is 3's remainder to 2 is also 1, 1 is printed, and understood, right? So on. So next we move next. So here n is 13. 13 is 0? No, isn't. It will call 6. 6 is 0? It isn't. It calls 3 is 0? It isn't. It calls 1. It's 0? It calls 0. 0 returns. Then when 0 returns, here comes the control for 1. See out 1% 2. 1% 2 is 1. It gives back the control to 3. 3% 2, 1. Gives back the control to percent to 0. Gives back the control to 13% to 1. Simple? Going back and then returning. हाँ सॉरी एन होगा ठीक. Using recursion to brute force, you can use recursion to go through every possible sub problem. Brute force is like, let's say you have to sum n integers. How would you do it? Without recursion. Loop लगा के 1 plus 2 plus 3 till n. What would be a smaller solution to this? Just print n into n plus 1 by 2. So brute force is sort of a simulation of what is asked in the question without intelligently playing with the solution or the question. Alright. So the examples could be all binary strings of a given length, all subsets of a given vector, etc. So what will be a time complexity of recursive brute force? It can be calculated as the number of recursive calls multiplied by additional complexity of the function, and can also be thought of as the sum of time complexity of each layer of the recursive tree. Well, what it says is quite mathematical and we won't be going into that. So simply it means, let's say you have a set or a vector and you have to print every subset of it. How many ways are there? How many subsets are there for a set n? 2 raised to n. So that is what it tells, that the time complexity is of recursive brute force is. So it is like that, and you will get a hang of it, and you will see that you won't be using brute force. And first of all, how would you be identifying brute force questions is, they have a quite larger time complexity. Like you said 2 raised to the power n. How much can it go? For 1 second, maybe it can go to 31, 32. That is also on a very higher side. Maybe 25 or 26 would make it in 1 second, would be in 1 second. So what can be n? 24 or 25, right? So that is a very small number. If you are given in a question 25, yes, the first thing that can come to your mind would be brute force, right? Let's say you are given n as 10 raised to the power 5. Obviously, you won't think of brute force. So brute force is a way of thinking, although it is not used as much in competitive programming. Alright. So this is just to give you an idea, and we'll be going upon some questions for that. Like these are brute force questions. There is just simple recursion happening in the first one. So let's say let's find out the time complexity, and we'll use maths like we did with the Fibonacci. So here, what will be the time complexity for the first question? That is this one. Think of it as the way I did Fibonacci. T of n is equal to T of n minus 1 plus O of 1. It takes one step to do all this thing, that is if n is equal to 0 return and recurs n minus 1. O of it can be done in O of 1, and the recurse function takes t of n minus 1. Alright, and if you solve this, it will be O of n. Second question then. It is very similar to Fibonacci, if you can see. Are you seeing a connection? Am I writing it correctly? Are you all with me? Plus how much? Multiplying by 2 every time. O of 2 to the power n, right? This one, t of n is equal to a little louder, more louder. T of, नाश्ता नहीं किया ना, जोर से बोलो, plus O of 1. This will, n is being divided by 2 and it will do it log of n times. So log n. This one, t of n is equal to 2t n by 2 plus O of 1. So O log of 2 to the power n. Well, that is also correct. If you were to see it as a tree, there would be n here, then n by 2, n by 2, n by 4, n by 4, n by 4, n by 4, like this, right? The height will be log n of the tree, and if you count the total nodes, it will come as n, or n minus 1 to be specific. So it will be O of n. Alright. Next, quiz 2. So first two questions are a little difficult, so let's start with the third one. What is the time complexity for this function? Worst case time complexity. Let me remind you, worst case. You have to find the worst case here. Whoever is speaking, please speak a little louder. किसने बोला? O of n. क्यों? Why? बहुत अच्छी बात. बताओ एक एग्जाम्पल. 11 लेते हैं. 11, फिर 9. पक्का? 11, 10, 5. So what's happening? Odd even, sort of like that. Okay. So the worst case would be a number like 2 raised to the power n minus 1. That would be the worst case for this thing. Because let's say if a number is odd, it will go to n minus 1. What will happen to it in the next iteration? It will be divided by 2. So in 2 steps, it is being divided by 2. A maximum of 2 steps to divide it by 2, right? It can also divide by 1 if the number was even itself. right? So what would be the time complexity? If we are to be exact, then it would be 2 of log n, 2 times log n. But since we do not consider constants, it would be log n, right? Is everyone with me? Clear? Make sense? Repeat. It would take maximum of 2 steps to divide a number n by 2, right or not? If it is odd, we will decrease it by 1. In the next step, it becomes even, we divide by 2. If it was even, it will be divided by 2 in one step only. So maximum of 2 steps to divide by 2. So 2 times log n. Alright? Because you are dividing it by 2. If it was 16, n was 16. It goes to 8, it goes to 4, it goes to 2, it goes to 1, and then it goes to 0. How many steps? What would be you think mathematically? Don't count, mathematically. What do you think is the number of steps? Like this. That's 16 to 8 to 4 to 2 to 1. Let's do this much. So how many steps it is taking? 2 raised to the 4 steps, and 16 is 2 raised to the power 4. Then it is obviously steps is equal to log n. Now understood? Great. Let's make a small modification. Now O of n, because if it is odd, it will stay odd and it will take O of n, and if we do it specifically, it would be O of n. Am I right? Well, it will not stop, or it will. So what will happen it will not stop, because after it is 1, when it will be 1, if n is 1, it will go to minus 1. So you sort of skipped the terminating condition. So that runs into infinite number of times. So be specific while writing your terminating conditions, and hence you should write your terminating conditions like this. Okay? So that in situations like these, you do not miss out. So that is very necessary. We'll make a small modification again. Three times n minus 1. Now the question is it progressing towards the base case? Well, it may or it may not. In some cases it may, that is when n is even, it will, and if n is not even, it won't. And in question, if n was 5, what would happen? If n was 5, it will call 14. 14 will call, 7 will call, 20 will call, 10 will call, 5. So we return to, from 5 we went to 5. So cycle, infinite number of times. Let's make a small modification again. Plus. It will always go to 1. Why? Great. So if you solve this question, I'll give you $10,000. All right, and I'll get $1 million from American University. So this is known as Collard's conjecture, and it is a conjecture. It is not been proven yet, but it you always goes to one, and you cannot tell its time complexity. And this was just to tell about Collard's conjecture, which I like, and that's not very much related to CP. So we'll begin and go towards our first question, that is to print all the subsets of a given vector A having n distinct integers. All right. So how to do that? Code. So start coding. This is a difficult question. You are given only a vector. So let me tell you what the function signature looks like. This is the function signature. So it will return a vector int, that is a 2D matrix of all the subsets, and it takes a vector. Let's say you make a recursive function and it takes A. All subsets of a given vector having n distinct integers. So what should I write here? ideas? What I am trying to do? So let's give a small background. So A is the size of the vector. We give it to n in the function subsets, and we create a vector matrix with a name result and a combination, and then we list combinations. That is, we call a function, and finally we return the result. All right. The list combination functions take 5 things, that is n, that is the size of the vector, a, that is the vector, the result in which we have to put the subsets, the combination which is the present combination, and int I, that is how much we have progressed so far. All right. So what can we do? How much we have progressed in the terms. What I am trying to do is, let's say you have a vector 1 2 3 4 5. So there are how many subsets? 2 power 5, 32. And how would you create them? You would, what you would do is, you would do it, there is first set that is empty, you multiply it by 2, and how do you are multiplying it by 2? You are making a copy of it and giving 1 to the this copy, and you are not giving 1 to this. You have an empty vector, you make a copy of it, and you give 1 to the one, and you do not give 1 to the first one. Now what you will do is, you make copy of them both, and you will give 2 to them, and you won't give 2 to the previous ones. And similarly, you make copy of all these, give 3 to the rest 4, and that is how all the subsets can be enlisted. Right? Is everyone with me? So that is what I am doing. So what should I do? What is the first thing to write? Terminating condition. And what should we do in the terminating condition? We have to push back the result, push back the combination into the result, right? If it is not, then what to do? You have to create a copy of the combination, right? Combination copy is equal to combination right. Then is there a confusion? Yes, there is. What is it? Why did we not do vector int ampersand combination? Yes, we can do. After all, we are making a copy. So if we are making a copy, the previous one won't be affected. So yes, we can do that. Yes, but that would also make a copy. Giving reference is great. That does not make a copy. That may like sort of there's a vector. Do you know about integer arrays or arrays? When you pass arrays, they are passed by reference, right? That is, if you add 3 to that array, it will be and print it in the main function. The 3 will be there. But if you do that kind of thing in vectors, it doesn't happen because vectors are passed by value. So we put an ampersand to pass by reference. So you have a doubt. What is it? You didn't get logic. So when I'll try to make you visualize, then you will see. So what happens is, we'll start with a smaller example of 1 and 2. Array is 1 and 2 now. I is 0. Result is empty. Combination is empty. N is 2. Alright? We list the combinations. Is n equal to I? 0 is equal to 2? No. What happens then? You make a combination copy that is empty. 2 empty vectors are there. One by the name of combination, one by the name of combination copy. You put a of 0, that is 1. A of 0 is 1, right? Into combination copy. So combination copy now has 1 and combination is empty. Increase the I by 1. We have progressed one step, and you list the combinations with those two vectors. What happens again then? This one gets an empty, this one gets with 1, and it happens the same thing as had happened here, right? From 1 to 2. Wait. So let's start with 1 then. We have already entered 1. Now combination is empty, right? I is 1, n is 2. It was the size of the A. Yes. You 2 vector A result, and this is empty, and this is 1. Is 2 is equal to 1? No. Combination copy is equal to combination. Empty, empty, both empty. In that empty, you push back A of 1, which is 2. A of 1, which is 2. First, so you increase I by 1, that is I becomes 2. And you call this function again. And this is also still empty, right? Combination is empty. We are pushing it in combination copy. So this is empty. N becomes 2, we push back the result. We push back the combination into the result, right? Can't an empty vector be pushed into a matrix, right? And it is returned. Secondly, this was the vector with only 2 in that, and that one is also put. Next, then it returns to where this had where the combination copy had only 1, and similar case the tree. Can you visualize it now? All right. And what about the rest? Can you all visualize it? At the back. All right. Am I making sense? Are you along with me here? Very good. Now a difficult question. It will return a empty with 1, 1 and 2 and 2. A matrix, right? Now, given n distinct coins, print the number of combination of coins with sum less than equal to given k. How can we do it? In the end, we are getting a result, right? If we check all the vectors which is in the result matrix, and count their sums, and if they are less than k we accept, if they aren't we don't accept, right? How will we do that? Let's say you are also given a k. K is the, you have to print the number of combination of sums of coins with sum less than equal to given k, and each coin can only be used by once. All right. So there are 3 coins, 1, 2, 3. Their value is 1, 2, 3. Given k is 2. What will be the combinations? If you see here, combinations can be only 1, all empty, only 1, then only 2, and nothing else. 3 combinations. So we get the result. Right? As simple as that. You are getting all the combinations. You just sum up the combination and check if it is more than k or not, or less than k or not. Simple. Well, is there a doubt? प्रीवियस वाले में डाउट है, क्या है? हाँ, हम कॉपी बना के चेक कुछ नहीं कर रहे. हमने कॉपी बना दी, उसके बाद हम क्या कर रहे हैं, एक वेक्टर में हम वो वाला एलिमेंट पुश कर रहे हैं और एक में नहीं कर रहे. अगर मैं, if I ask you how will you make a how will you create all subsets of a vector, how will you do it? हाँ, 1 by 1 कैसे? 2 तरीके हैं सारे सबसेट्स बनाने के. क्या हो सकते हैं? या तो पहले देखा सिर्फ एक सबसेट जिसमें कोई एलिमेंट नहीं है, वो सारे सबसेट जिनमें एक एक एलिमेंट है, वो सारे सबसेट जिनमें 2 2 एलिमेंट है, ऐसे करके होगा. या फिर दूसरा तरीका क्या है? दूसरा तरीका ये है, मैंने एक खाली वेक्टर लिया, ठीक, उसकी 2 कॉपी बनाई, एक में 1 डाला, एक में 1 नहीं डाला. मैं ट्री के फॉर्म में बताता हूँ, वेट. यहाँ खाली वेक्टर, एक में 1 डाला, एक में 1 नहीं डाला, इसमें 1 आया, इसमें नहीं आया. उसके बाद एक में 2 डाला, एक में नहीं डाला, इसमें 2 डाला, इसमें नहीं डाला. 1 2 आया, सिर्फ 1 2 एम्प्टी. ये तरीका भी सही है ना? तो यही तो किया. फाइनल, हम इसको, ये एक वेक्टर धीरे धीरे बढ़ते जाएगा, ठीक. इसको हम पुश कब करेंगे रिजल्ट के अंदर? जब ऑलरेडी हम एक बार सारे एलिमेंट्स प्रोसेस कर चुके हैं, है ना? क्योंकि मान लो अगर हम बीच में डाल देते हैं और आगे जाके कुछ चेंज हो जाता है उसमें, तो वो हमारा चेंज उस वेक्टर में नहीं रहेगा ना, ठीक है? हम सारी लीव्स को पुश करे जा रहे हैं। आफ्टर ऑल पुश तो हमें ये लीव्स करनी है ना, बीच में तो हमें पुश करना ही नहीं। तो ये लीव्स पुश करा हमने, तो वो कब होएगा? जब n इक्वल टू आई हो जाएगा। सबसेट एक फंक्शन का नाम है, रिजल्ट वेक्टर एक मैट्रिक्स है, ठीक? उसमें ये 4 वेक्टर्स हैं जो कि सबसेट्स हैं, ठीक? और इनमें ही हम इनका सम देख रहे हैं कि एक तो ये हुआ और एक होगा 1 2 3, 1 3 2 3 और एक सिर्फ 3, ये 8 बनेंगे उन 3 से। इन सब का सम करके देख लेते हैं, ठीक? इज एवरीवन विद मी? अब समझ में आ रहा है? कोई दिक्कत तो नहीं? अभी भी रुक सकते हैं? चलो ठीक है, आगे बढ़ते हैं। Backtracking. Now what is backtracking? In simple words, it is intelligent brute force. All right. So what intelligent brute force is? You can omit some of the steps. Like, for example, in the previous question, let's not go to that. We'll go to it in the next slide. Let's first read this slide. Backtracking is brute force recursion, but it is far more efficient as it can skip over many unnecessary recursive calls. Backtracking will stop at the first instance where some given condition is not fulfilled. This process will remove entire subtrees from the tree. कैसे? ऊपर वाले में मान लो ये जो ट्री बना, इसमें यहां 1 2 ऑलरेडी 2 केसेस ज्यादा हो गया, तो इसका जो नीचे ट्री बनेगा उसको हम देखते ही नहीं, है ना? सिमिलरली यहां और मतलब कि अगर मैं 1 कर दूं कि अगर, तो यहां जो इसके नीचे ट्री बनेगा उसको हम देखते ही नहीं, है ना? तो एंटायर सब ट्रीज चले गए। कॉम्प्लेक्सिटी कम हुई, टाइम कॉम्प्लेक्सिटी हाँ हुई, द कॉम्प्लेक्सिटी रिड्यूस्ड, but it will not reduce very much, right? If I were to ask you, even by removing these trees, that what will be the time complexity, it will approximately be of the same order, right? So but it is faster, but backtracking is faster, and simply we are not able to calculate. So we say it is efficient, but we don't know how much efficient it is. The worst time complexity is still the same, because that efficiency depends upon the values of the parameters like k, right? And what the vector was. So the same problem, given n coins, print all the values you can make with some combination of coins as long as the sum does not exceed k. Brute force will go till the last possible index and then check if the sum does not exceed k. Backtracking will stop at the first index where the sum exceeds k. So let's do this. So we'll modify this first of all. That is, we will still apply brute force, although we'll not make a result vector this time. Which code will be provided in Discord? नोट कर ले। जो कि रिजल्ट वेक्टर को रिटर्न कर रहा है, जो कि एक वेक्टर वेक्टर इंट है. So, what were the changes I did? First of all, let's see the main function. There is an vector A with 1, 2, 3. K is equal to 2. And you call the subsets function with A and K. Right? Right? Subsets takes a vector A and a int K. You give it the n as the size of A, and answer is 0. That will be the final answer. Okay, that is the number of combinations that we'll have to print. So it lists the combination. It takes in 5 parameters, NAK, 0 and answer. And finally, since answer is passed by reference, answer gets the value, what it is, and it's printed out here. Okay? Is everyone with me? So let's go on to the main function, that is list combinations. It has an integer n, vector A, sum is k, that is, this time we are reducing the numbers, and if that number is less than 0, if that sum becomes less than 0, then obviously that won't be the answer, because the sum has exceeded k, right? Sum is sort of, we are going backwards, so sum is like we have exceeded k. So like sum is k at k first, there are two cases, either you decrease 1 or you don't decrease 1. So we are this time k में से decrease करते हैं. So if that, when we decrement, if it becomes less than 0, obviously then it won't be the answer. ठीक? Is everyone okay with it? Make sense? Understanding what I'm telling or what I'm speaking? Then we have I, that is the same as we progress, and the answer. In place of result, that is the matrix, we take answer. So if n is equal to I, then that is we have reached the end of the tree. And if sum is greater than equal to 0, we increase the answer by 1. All right, at the back. All right, there, here. Okay, next. So there were two combinations before, that is combination and combination copy. There are two sums here, that is sum and new sum. Sum is the previous one and new sum is when we reduce it, and we increase I by 1 because we have progressed by a stage, and we call both the functions. Sum is the total thing, that is k में से हम डिक्रीज कर रहे हैं धीरे धीरे. तो k में से या तो हमने 1 डिक्रीज किया या नहीं किया, 2 डिक्रीज किया या नहीं किया, 3 डिक्रीज किया या नहीं किया. जैसे पहले सबसेट में डाल रहे थे, 1 डाला या नहीं डाला, 2 डाला या नहीं डाला, 3 डाला या नहीं डाला. इस बार हम डिक्रीज कर रहे हैं. ठीक 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 ठीक. ओके, सो सही समझ में आ रहा है सब? एवरीथिंग क्लियर अभी तक? अब हम लाएंगे बैक ट्रैकिंग. सो व्हाट कैन वी ब्रिंग, हाउ कैन वी ब्रिंग बैक ट्रैकिंग हियर? क्या कर सकते हैं हम जो बैक ट्रैकिंग आ जाए इधर? क्या होती है बैक ट्रैकिंग? सिंपल, कुछ ऐसा काम करना है कि एंटायर सब ट्री खत्म हो जाए. क्या, कहां पर हम कुछ ऐसा चेक लगा सकते हैं कि मुझे उसके बाद जाने की ही जरूरत ना पड़े? छोटा सा मॉडिफिकेशन और टाइम बहुत ज्यादा अच्छा हो जाता है. क्या छोटा सा मॉडिफिकेशन कर सकते हैं, सोचा? व्हाट कैन वी डू? हिंट है, हिंट दिया हुआ है मैंने पहले. ब्रूट फोर्स विल गो टिल द लास्ट पॉसिबल इंडेक्स. बैक ट्रैकिंग विल स्टॉप एट द फर्स्ट इंडेक्स वेयर सम एक्सीड्स के. अब कुछ आया? कुछ छोटा सा, बहुत बड़ा नहीं, बहुत छोटी चीज है. इधर से कुछ हल्का सा. कुछ कहना चाहते हो, बताओ. पीछे, हाँ, क्या कर सकते हैं? अगर, चलो मैं बताता हूं. So if sum less than 0, खत्म. लगा कुछ इफेक्टिव किया हमने? डिड वी डू समथिंग वेरी बिग? बताओ. सम इज लेस देन 0, पूरा एंटायर ट्री, सब ट्री गायब हो जाएगा इससे. मानते हो? लगता है इधर Do you understand that the entire subtree will be removed with a small example? बहुत अच्छी बात है, एग्जाम्पल से बताते हैं. सेम एग्जाम्पल बताएंगे जैसे पहले बताया था. कहाँ गया ये? अभी अच्छा, इस बार सम लेके करते हैं. ठीक, 1 2 3 4 के छोटा से लेते हैं, 2 लेते हैं. नहीं, 2 ज़्यादा छोटा हो गया, 3 ले लेते हैं. के इक्वल टू 3. सम क्या हुआ अभी? यहाँ नीचे हमने के ही डाल दिया था ना. इस समय सम भी 3 है. पहला डालते हैं. अब क्या होगा? यहाँ सम इक्वल टू 3, सम इक्वल टू 3 एंड सम इक्वल टू 2. यहाँ 1 था, यहाँ 1 नहीं था. Right? Sum at left side we have sum 3 because we did not decrease it by 1, but on the right side we have sum equal to 2 because we decreased it by 1. Then हाँ, वो in the next iteration sum ही बन गया. ऊपर अगर हम फंक्शन सिग्नेचर में जो पैरामीटर है उसमें तो सम ही हो गया ना. तो मैं यहाँ न्यू सम भी लिख देता हूँ, कोई बात नहीं. ठीक, इसके बाद उसके बाद ये सम इक्वल टू 2 बन गया. ठीक, अब 2 तो सम इक्वल टू 3 और सम इक्वल टू 1. यहाँ पे 2 आया और यहाँ पर सम इक्वल टू 2, न्यू सम 0, सम 0 अगली इटरेशन में. ठीक, फिर सम 3, न्यू सम 0, सम 1, न्यू सम -2. और इसके बाद अगली इटरेशन में हम क्या देखेंगे? दैट दिस इज लेस देन 0 एंड लेस देन 0, तो इसके नीचे हम करेंगे ही नहीं. तो यहाँ पे भी एक 4 वाला छोटा सब ट्री आना था ना, वो हमने किया ही नहीं. तो हमारा इफेक्टिवली टाइम कॉम्प्लेक्सिटी कम हो गई. उसके बाद हम कहाँ जाते हैं? सम 2. इसमें एक होगा 2, एक होगा -1, फिर नेगेटिव चला गया. इसमें 0 -3 नेगेटिव चला गया, नहीं करेंगे. इसके बाद यहाँ पे 4 आएगा लास्ट में, वो फिर जो भी सारी लीव्स आएंगी वो हम कर लेंगे. अगर यही हमने बैकवर्ड किया होता तो, या फिर एरे ऐसी होती तो 4 3 2 1, तो सम पहले 3 होता, यहाँ पे 3 आया, यहाँ पे -1 आया. ये पूरा ही सब ट्री इतनी ऊपर से गायब हो गया. तो इतना हम नीचे गए ही नहीं, मतलब पूरा एक बहुत बड़ा सब ट्री गायब हो गया. ठीक, हाँ, यहाँ पे 3 लिया, 4 से स्टार्ट किया इस बार, तो यहाँ -1 हो गया ना. ठीक, ओके. फाइनली द लास्ट प्रॉब्लम ऑफ द डे. यहां करनी है या होमवर्क दूं? दोज इन फेवर ऑफ होमवर्क? सो मैनी यार. ठीक है, देन आई विल गिव अ स्मॉल इंट्यूशन एंड देन विल लीव द क्लास. ऑल राइट. एंड यहाँ पर हैशटैग्स और फुल डॉट दिया हुआ है. आई प्रेफर 0 1 से कर लो आप लोग. तो I'll first of all explain the problem. So let's say you have a matrix like this, 0 1, and you start from here, you have to reach here, What are zeros? What are zeros? What are zeros? What are zeros? Sort of, they're obstacles. Consider a rat here, and it has to. There is a cheese. चीज ही पसंद होती है ना रैट को, या कुछ और होता है? चीज, ठीक है चीज. कुछ और खाने का आइटम बोलना है, वो भी बता दो, वो रख देंगे. रैट को पसंद आना चाहिए. क्या? नहीं, वो नहीं. हम हिंसा में विश्वास नहीं रखते. ठीक. सो rat can go either right or down. All right. So, and it can only follow the paths given by ones. Consider zeros as obstacles. So a possible path here will be right. So what you have to print is a possible path, that is a matrix. And how will you do that is where backtracking comes. So you have to use backtracking here, and how will you do that is what do you think? Let me take your inputs first, then I'll give mine. Ideas? Ideas from here? No idea? Get idea. यहाँ पे कोई आइडिया? हाँ. All right. Very good. Okay. Very good. Louder. Great. So let's combine both of their solutions. So what they said is, first you go right, you find a solution there. If there is no solution on the right side, you come back, you go down and find a solution. If there is no solution then also, then you return and saying that the answer does not exist. And if there is, then very well, you have found the solution. So this is what is actually going to happen in this case. And an interesting phenomena comes when we modify the problem to this, up and left. Now what would happen? The down and right case was simple, but the up and down case has also come here now. What to do is the question. How to do will be my follow-up question. So, what to do? Maybe you can enhance your idea. Maybe you can enhance your idea. Okay. Great. But there is a loophole there. What the loophole is? Infinite recursion. And how that will be, like, let's say in between of this whole matrix you find a small square matrix of ones. You may be looping in here, right? You have to eliminate this looping also. That is the main thing. So how you will eliminate this looping is a problem here, and that is done by keeping a variable. Like if you have come up till this position, you say you give it a 1. Let's keep it a boolean value, and let's say I have come up till this position, I will give it till 1. Then if I come again to this position, or then I'll check the next position. If it is 0, I will continue. If it is a 1, it means I've already come to that position, right? So I will not come there. So, and that means I'm in a loop, and I will terminate my that recursive or that path. I will terminate that path there. All right. So we'll have to do the same thing, that is up, down, left, right. But in case there is some sort of a loop in between of the path, we'll terminate it by using this boolean value as storing whether we have already reached this position in the matrix or not. All right. Am I clear? So will you be able to code it? Well, as first time, it is a bit difficult, and you should start with the down and right problem first. That will be very easy in comparison to up and left. All right. So I would recommend you to first solve the down and right problem, and if you are able to get it right, kudos to you. And then you can try the up and left problem also, that is down, right, up, left. And in that, although it looks very difficult to implement, but like the previous case, there is just a small modification and you'll get to the answer. Only this condition you will be checking, that is if that solution of I of j is equal to 1, we already terminate. All right. So let's proceed to the next slide, and this will be your homework for today. I know you have your MSCs, mid-semester examinations, but do try to give a half an hour to this problem. That would be sufficient. And this problem is also on Geek for Geeks, where you can see the solution if you do not come up with your own. So these are the practice problems. We will be sharing these slides on Discord. All right. And for more practice, that is, since you are a beginner in recursion, what you can do is you can solve some random problems using recursion instead of a loop. All right. So you find any solution, you find any question, you don't go for a loop, you go for recursion to solve it. So that's all for today. Thank you, everyone. We won't be having the next class on Sunday because of the mid-semester examinations, and we'll be continuing next week with a different set of tutors, and we'll try to conduct that in an online mode.